All right, number 3, graph the equation, and we've been given y equals negative quantity x plus 5 squared plus 4. And hopefully you will recognize from class that this is going to end up being a parabola. Now, we may not know exactly what this parabola is going to look like, but based on the fact that this is a quadratic equation, meaning the highest degree of this equation is 2, we know this will be a parabola in some form or fashion. Now, there are really two things that I would probably recognize from this equation right off the bat. First and foremost, I would recognize the fact that this equation is in vertex form. And generally, vertex form is given by y equals a times quantity x minus h squared plus k. And what's nice about vertex form is that we can quickly look at our given equation and identify the vertex right off the bat, which is nice. And we're going to do that in just a second. But the second thing that I would recognize is that based on this negative here at the on the outside here, we are going to have a parabola that opens down. Remember, for this particular test, on this practice test, you will see parabolas that either open in the upwards direction or they're going to open downwards, all right? And because we have a negative here on the outside of our parentheses, we have a parabola that will ultimately be opening down. So those are the two things that I would recognize first and foremost, that we're in vertex form, which means we can quickly identify our vertex, and we know that this parabola, when it's all said and done, is going to be opening down. All right, let's go ahead and find our vertex. Now, based on the fact that we have x plus 5 inside the parentheses, we know that our h value from the vertex is really going to be negative 5. Remember, we talked last practice review about horizontal translations and vertical translations, and we talked about how with horizontal translations, which occur inside the set of parentheses, that whatever you see here for your h value, you're really going to take the opposite of. And so the fact that we have x plus 5 means that our h, our horizontal translation, is really left 5 units, right? And so our h is negative 5. And then for our vertical translation, our up and down movement on the y-axis, we take whatever we're given. In this case, we're given a positive 4, so our k is 4. And now this just becomes the point negative 5, comma 4. So we know exactly where our vertex is, so we're off to a good start. Now that we have our vertex, what I would do is create for yourself an xy table, because what we're going to do is we're going to choose 2 or 3 x values to the left of negative 5 and 2 or 3 x values to the right of negative 5. That way we have a pretty good idea of what this parabola is going to look like when we sketch it. All right, so now that we have our vertex, I'm going to take the vertex and put that point right in the middle. And based on this information, I'm going to choose 2 x values to the left of negative 5, meaning smaller than negative 5. And then I'm going to choose 2 values to the right of negative 5, larger than negative 5. So let's go ahead. Let's not make our lives any more difficult than they have to be. Let's just choose negative 6 and negative 7. Those are 2 values to the left of negative 5. And we can choose, how about negative 4 and negative 3. Those are 2 values to the right of negative 5. And now let's go ahead and find what the corresponding y values are for these x's. So I went ahead and created another slide for us here, and we're going to work everything out together. So let's see what the corresponding y value is when x is negative 7. So when x is negative 7, we're going to plug that in and see what happens. So we end up with y equals negative, plugging in negative 7, right? This is our x, plus 5 squared plus 4. All right, let's clean this up a little bit. So we still have that negative on the outside, and inside the parentheses we have negative 7 plus 5 is negative 2 squared plus 4. Again, still cleaning up. We have that negative on the outside. Negative 2 squared is positive 4 plus 4. All right, we can now finally distribute that negative that was on the outside, so we end up with negative 4 plus 4, and then that gives us 0. So when x is 7, the corresponding y value is 0. And again, this just becomes the point, negative 7, comma 0. All right, let's go ahead and see what our corresponding y value is when the x is negative 6. So negative 6. Y equals negative 6 plus 5, quantity squared, plus 4. That negative just comes down on the outside. Let's clean up here what's on the inside of the parentheses. So negative 6 plus 5 is negative 1 squared plus 4. Negative still comes down. Negative 1 squared is positive 1 plus 4. Finally, we can distribute that negative on the outside, so we end up with negative 1 plus 4, and that gives us positive 3. So when x is negative 6, the corresponding y value is positive 3. We've got our vertex there in the middle, and now we'll take a look and see what happens when x is negative 4. All right. So negative 4. So we have y equals negative 4 plus 5 squared plus 4. Negative on the outside. Negative 4 plus 5 we know is positive 1. Again, the negative comes down. Positive 1 squared is still positive 1 plus 4. We're going to distribute that negative through, so we get negative 1 plus 4. And again, we end up with positive 3. So when x is negative 4, the corresponding y value is positive 3. And for this last one, I'll let you go ahead and work that out on the side. But when the x is negative 3, the corresponding y value is 2. All right, so now that we are, actually, you know what? I don't think it is. It's 0, isn't it? Sorry, I was looking at the wrong thing. All right, so when x is negative 3, the corresponding y value is 0. And that just becomes the point negative 3, comma, 0. All right, so now that we've got our points, let's go ahead and come back to the previous page. And I'll go ahead and quickly fill this in here. So this was 0, 3, 3, 0. So these become the points negative 7, 0, negative 6, 3, negative 5, 4, negative 4, 3, and negative 3, 0. All right, let's go ahead now. We've got all our points. Now we just have to graph. I always like to start and graph my vertex first. So we're going to go negative 5. So 1, 2, negative 3, negative 4, negative 5, and then up 4. So 1, 2, 3, 4. So right here is our vertex. All right, again, we said originally that this parabola is going to be opening down, right? So we would expect our points to be below the vertex, all right? So let's see. Let's graph negative 7, comma 0. So negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. And we're not going up or down any on the y-axis. So there is negative 7, comma 0. How about negative 6, comma 3? So there's negative 6, positive 1, 2, 3, right there. And then negative 4, 3, so negative 1, negative 2, negative 3, negative 4, 3, right there. And lastly, negative 3, comma 0, negative 1, negative 2, negative 3, comma 0. And now that we've got all of our points on our graph, we can go ahead and connect these points. Oops. And there we have it, our parabola. All right, so again, identify what form your equation is in. If it's in vertex form, some of the work is already done for you because you can quickly identify your h and k. Recognize whether or not your parabola opens up or down. Again, if it's a negative here on the outside, your parabola is opening down. If it's positive, it'll be opening up. Once you have your vertex, go ahead, create an XY table for yourself. Put the vertex right in the middle, and then choose 2 or 3 values, x values to the left of your vertex, 2 or 3 x values to the right of that vertex. Go ahead and evaluate, find what the corresponding y values are for those x's. You'll have your points. Go ahead and graph them and connect the dots, and you are good to go. So there is number 3. We graphed the equation.